ناخذ الإكسيرجي أناليسيز لمنظومات الهواء تشمل التكييف والتبريد. هاي المنظومات تختلف عن البقية إنه راح يكون بها ماس ترانسفير. إذا كان هذا عندي كويل صار لي كوندنسيشن فالهواء راح يفقد كتلة، أو إذا كان عندي إضافة الرطوبة أو كولينج تاور أو اير كولر تعتمد على إضافة الرطوبة وسحب الرطوبة، لذلك راح يختلف الإكسيرجي لهذا النوع. نطلع على المعادلات لاحقا. ناخذ المثال: in an air conditioning process, air is heated by a heating coil in which hot water is flowing at an average temperature of 18 degrees centigrade. Using the value given in figure to determine the Exergy destruction and Exergy efficiency for this process. The atmospheric pressure is 101.325 kilopascal. Dead state equals ambient condition. This is mean the dead state equal to T1 and Phi1. Specific heat of air 1.005 kilojoule per kilogram Kelvin. For water vapor is 1.87 kilojoule per kilogram Kelvin. The air constant is 0.287. This is the system: T1, T2, heating coil, T coil 18 degrees centigrade, the volume flow rate 0.58 meter cube per second, and phi 70%. نطلع على المعادلات اللي حكينا عنها للإكسيرجي، راح نشوفها بهذا الشكل. هنا عندي الثيرمال إكسيرجي، وهذه الكيميكال إكسيرجي، وهاي الميكانيكال إكسيرجي. الثيرمال إكسيرجي due to temperature difference between the ambient temperature or the inlet temperature and dead state temperature, and the chemical exergy is the difference between the moisture content of air and the moisture content of the dead state, while the mechanical exergy is due to pressure difference. Since in the air conditioning system the pressure always constant, thus equation 3 may be eliminated. The total exergy of the system, the summation of thermal exergy, mechanical exergy, and chemical exergy. This is the final equation of the overall exergy of the moist air. على البرنامج Engineering Equation Solver نسوي التحليل الإكسيرجي والتحليل الحراري للمنظومة. Exergy analysis of a simple heating system. نبدي هنا لازم نبدل الخواص thermodynamic properties. ناخذ air H2O حتى نميز انه اكو خليط بين بخار الماء والهواء، وبعدين نسوي done نكمل الشغل. variable temperature 1 اخليها، والphi relative humidity خليها unitless، الفوليوم للهواء 0.5، الدراي bulb temperature 2، والضغط الديج ستيت اللي نفس الضغط راح يكون P1 و P2، والديج ستيت T1 يساوي لي T نوت، والسي بي للاير 1.05 كيلو جول بير كيلوغرام كلفن. نلاحظ كتبت دراي بالب تمبرشر نوتي حتى اميز دراي بالب عن ويت بالب، تكون العمليه اسهل لي. في بعض الاحيان استخدم الويت بالب. والفيبر 1.87 كيلو جول بير كيلوغرام كلفن، and الاير كونستانت or gas constant 0.287 كيلو جول بير كيلوغرام كلفن. ابدي بالنقطه واحد مثل ما تعودنا الامثال دي اللي هو الار دولار ساين، لازم اعرفه ما عرفته سابقا. التي راح اعرفه، والار اللي في هيوميديتي يساوي لي فاي 1، ولازم ادخل الضغط بي يساوي لي بي نوت. هاي قلنا اعرفها لازم، اللي هي مثل ما قلنا اير H2O، the volume or specific volume of the air. This is the properties. Copy paste here. Moisture content at 0.1, hum rate, what? This is volume, not volume. Mass flow rate to the volume, to the specific volume. The heating process is achieved at constant moisture content, and that means no moisture is added or rejected from the system. So omega 1 should be equal to omega 2. Enthalpy at point 2 related to the dry bulb temperature 2 and phi 2 p psi p naught okay, not this will be moisture content, not relative humidity. Okay, data state, I shall define the data state. Omega naught numerator or T equal to data state, and the relative humidity is constant, is the same as the inlet temperature. Exergy analysis of the system. Here there is chemical exergy and mechanical exergy wrote on the word. Maybe this simple condition for me to calculate this one. This is the final equation on the word. Copy from the word and paste to the energy. This is the final shape of the equation. Should be accurate. Okay, this is the properties of the point 2. Shape of the equation like that. Okay, here you can see the chemical exergy and thermal exergy, and the total exergy for point 1 is 0. This is because point 1 is the same as the data state, so there's no exergy difference between point 1 and point 2. And for the second 2 or point 2, the chemical exergy is equal to 0. This is because no moisture content transferred between point 1 and point 2 as is seen here. It's the same moisture content. There's no moisture added or removed from the system. This is the overall exergy of point 2. That's a summation of chemical exergy and thermal exergy of the point. Heat balance of the duct system equal to the M1 H1 minus M H2 Q heat. M1 should be equal to M2 steady state. Exergy destruction. Okay, M1 psi 1 ناقص M2 psi 2 plus thermal exergy due to heat transfer between water and air. This is the coil temperature. I should define the coil temperature. Okay, this is the final result. Exergy efficiency of the system. This should be equal to the increase of thermal exergy of air to the exergy of heat. This is the thermal exergy of air, absolute value, the absolute value of exergy due to heat transfer I should define the thermal exergy and exergy due to flow. The thermal exergy is the exergy due to heat transfer, psi heat to dq. This is the thermal exergy. This is not thermal. The exergy due to flow of substance equal to change of exergy of the system. This is the final result. Exergy efficiency 0.1289, exergy to heat 1.869, due to flow minus 0.2409, and the diffraction 1.628. This is the first example in the exergy analysis of HVAC system, and I will give you the second example about the mass transfer. Thank you very much.